I think we are live now. Okay. Oh, all right. So yeah, I can see myself here. Uh, all right. So hey everyone, how is it going? It's been a long time ever since I have taken essentials, and it feels good to be back. All right. So let me actually see here like how many people are like we have in the chat. Okay, so we have around like 70 people, and just tell me guys like where are you from and like how are you doing right now. Just like let's actually have a brief 2 or 4 minutes of introductory session, or I would say like streaming. So where are you from guys? Like just tell me. All right. Okay. All right, so we have a quite diverse audience here. I can see, like from north to south, like everywhere. Okay, great. All right. Okay, great. Okay, so the today's objective and today's session or the essential will be all about machine learning for rookies. Okay, and after 5 days, what you can expect, you can expect to have a better understanding of how does the machine learning process actually works. We won't be able to dive into nitty gritty details of an algorithm or something like that, but you will be having a better understanding of how to tackle a machine learning problem in the first place. And after that, you will be also having an understanding of if you really need machine learning or not. Like there's a saying in data science or in machine learning in general, like a good machine learning engineer knows when and when not to use machine learning, for the data. Like if it is solvable without machine learning, you should definitely do it that way as well. But this entire essential is all about machine learning, so we won't be talking about it into that aspect for sure. Okay, so let's actually see how exactly the machine learning actually works. And you know the let me share the screen again. I think my screen is not being shared right now. I can see that. Okay, guys, can you see my screen? Okay, now is it shareable? Like, can you see it? Okay, now I can see that too. Okay, all right. Now is it okay? All right. So let's try to understand what exactly the machine learning is all about. Okay, I'm having my nariyal here. Okay, and you can have something to drink or something to eat. Like it, this session will be all about introduction and kind of a chill session, like what the machine learning is all about. And we won't be delving into much more details or much more technical part, but you will be definitely having an understanding of like in a fun way what the machine learning is. Okay, so let's begin. Right. So what exactly the machine learning is? Okay, and like why do we need it in the first place? Let's try to understand this. Okay, so right, come here. So machine learning is the process of extracting or extrapolating the pattern out of a data. Okay, so what we do in machine learning, let's say if I have to put a what is machine learning. Okay, okay, basically finding patterns, you know insights or observations out of data and performing tasks such as you know uh, performing tasks such as regression, classification, etc. Okay, this is actually quite a journal definition that you can etc. But how exactly do we do that? It's a question. Is right? Okay. So coming back to our here. So what exactly it is? So now you can see a simple what machine learning is. So when an algorithm learns from the data. Okay, I will going to give you a better example of how exactly it actually learns from the data. But right now, just actually take my word for it. I will gonna come back to the very example how exactly this statement is making sense. But when an algorithm learns from the data, okay, so that part can be can take an umbrella of machine learning. Okay, so but the question is, why do we need machine learning in the first place? You may have heard like machine learning can perform miracles, and AI is taking over the world, but how and why do we even need it in the first place? Okay, let's actually try to understand that. Okay, uh, consider the following scenario where you have been asked to write a spam filter. Okay, what exactly the spam filter is? You may have heard about a spam filter. What exactly the spam filter is? Like, you may have even used it in your email, or maybe somewhere like where you get notifications, okay, about text or something, or email. Okay, so let's say you actually pass an email, and that is actually a spam filter. Okay, and this spam filter will going to determine like if this email is a spam or not a spam. All right, not a spam. That is your spam filter. But how do we actually come up with this spam filter, and how exactly we can make it is a question. And just to actually give you a fun fact, like spam filter or your email classification, as we actually say it, okay, was the very first machine learning model, was the very first machine learning model that we built in maybe in 90s. Yes, machine learning is that old. All right. Okay, coming back to it, right? So why do we actually need it? Okay, so let's actually try to understand it here. Okay, so the try to understand this task here. Okay, suppose like okay, so what we can do here in order to build a spam filter, let's actually try to understand this. Okay, so say you have been given a task for writing a spam filter program. Okay, and the pseudocode for writing a spam filter goes like this. Okay, let's say spammy words are, let's say you have you, for you, or and free, capital in capital. Okay, these are your spammy words, which you actually see when you in your subject, right? You have a subject in each email, right? For sure. So basically, how does your email formation actually works? Like you have a subject here, and then you have a body, right? Okay, and in that subject, you actually found these three words, or like more, like, but these three words, whenever you actually see that, you actually come up with a intuition, or you say like, okay, whenever I am going to see these these words, I'm going to declare it as a spam. Okay, otherwise not a spam. Okay, so what you will gonna do here, you will just basically you will just gonna write a simple, let's actually try it here, a pseudocode. So if word, okay, not in, you, for you, and free, okay, then I'm going to declare not a spam, else is a spam. Right. Sorry. So what exactly do I mean by that? If the word is available, like if it actually exists between these three words, like if actually it is from here, if word from the subject, of course, then and only then I'm going to declare it as a spam. Otherwise, I will not going to declare it as a spam. But there is a problem here, and this entire scenario is all about like why do we even need machine learning? Okay, so there is a problem here. What exactly, can anybody tell me like what exactly the problem could be here? Just actually let me know in the chat. I'm actually writing my own answer here, like my own interpretation. Okay, the problem that I can see here, what if the fraudster, what if the fraudster actually come to this knowledge, like, okay, you might be you might be flagging these three words. Okay, what if okay, they actually know about this, like if they are being known, if they have this knowledge of like we are flagging these three words, then what they can do, like they can simply use this, instead of this u, they can use this u or this for you. Okay. And they can even remove this free. And now your system won't be able to detect if it is a spam or again not a spam. In order to detect that, again you have to write innumerable number of flags. That is where machine learning actually shines, right? Machine learning algorithm, okay, actually works on a principle called uh, okay, universal. I will come back to it. What exactly it is? Universal approximation theorem. I will going to come back to it. What exactly it is? Okay, just in a while. Theorem. Okay, let's try to understand this, how exactly we can actually solve this problem here. Okay, so coming back to it. Okay, we have already explained like problems with this approach. What exactly the problem is? It is all about. Okay, but when we talk about this, so what we can do here, let's try to understand. What if I actually come up with such function? Okay, let's actually try to understand this. Okay, again coming back to it. Okay, let's say you have emails. Definitely you will be having email data, right? And in this email you will be having spam and non-spammy emails. So what if in a way what if I can actually come up with a function such as right, my spam and my not a spam. Okay, and we can somehow you know divide this data from spam to non-spam. Of course there will be some problems, like there will be some errors though, but little error is somewhat doable, like not an issue. But that is where we basically say, like, with this much probability, which or with this much confidence, our model can tell, like, let's say 98% of the times our model will be correct. Like, it is a talk in all in itself. But right now what we can do, we can come up with such functions, right? We can come up with such function, or line, right? In this case it's an xy plane, right? It's your y and this is your x. So we can come up with such xy plane. Okay, in an xy plane we can come up with such line which can separate my data, right? This line definitely can separate my like in this case, this data is what your spam data. Like, spam data is what it is, like your red points. Okay, and this one is your non-spammy, the green ones. So what if we actually come up with this line? The problem will be solved. Like, what exactly the benefit for this approach? Like, we won't have to write innumerable number of flags. Okay, that actually solves the problem. So that is where when the data accumulation is large, or somewhat of when the data accumulation is large, okay, and we want to find some pattern or estimate. Okay, we generally use machine learning. I'm saying here generally, to achieve it. All right. Okay. All right. So again, coming back to our this. Okay, so this is what I am actually trying to explain here. Okay, so these are again your spammy, or I would say like the spam emails, and these ones are your non-spam emails, and this is your line. Okay, and this line you may have heard about a lot, maybe like a lot. Okay, this line is your machine learning model. Yes, your machine learning model, your machine learning model is nothing but a function. Okay, machine learning model is nothing but a function which follows certain rules, which follows certain constraints. Constraints. Okay, fx here in this case mx plus c, and this fx is your linear model. Why? Why linear? Why? Because it separates linear data. Simple. But like machine learning is quite straightforward. If you can imagine data being projected at xy plane, everything becomes simple. Okay. Okay. All right. So what we can do, what we do basically, we come up with an estimated model or estimated function. Here, this fn is a function, which we also call as, also, you know, let's just say, call as what? ML model, a model in machine learning. All right. Okay. So this is your, like, I just gave you an intuition about like the what the machine learning is and the model is all about. Okay. Okay. All right. Coming back to it. And now, like machine learning applications, like just to actually give you a hint of it, like what the machine learning applications can do. Machine learning applications, wherever you see data accumulation, okay, in one way or the another, we can definitely apply machine learning. Let's say for computer vision. Okay, in computer vision, vision basically means, like as the name suggests, images or videos. Like, okay, like the way we perceive data, through our visual system, we try to give the same power to our computers as well, to perceive the data in a human interactive way, in a human way. Okay, let's say for the computer vision, we know like our brain is quite complex in terms of as a biological machine. But certainly your when you will going to develop or going to create something artificially, like it won't be that complex, it won't be that powerful for sure. But now ever since, like from the past 7 or 8 years, machine learning, or in certain domain, like in deep learning, has advanced a lot. Like you can literally perform high end recognition tasks. Okay, so such tasks like determining if an image is of a cat or a dog, right? Not only that, it is now even possible to do medical imaging. Like we have data, X-ray data, right? We can determine just from the X-ray if a person has pneumonia or not, tuberculosis or not, right? We have DKIM images, DKMI, I believe, okay, which can tell like it's a brain image. And from this brain image, we can deduce like if a person has a hemorrhage or not. Yeah, that powerful. Like machine learning and deep learning has become this powerful. Okay, and not only that, not only in the computer vision, we can certainly perform NLP tasks as well. Natural language processing. Or understanding, which we also call NLU or NLP. I will just going to put a U here. Okay. I'm sorry. All right. So what exactly the natural language processing is? Like when we process, sequential data. I'm coming back to it. What exactly the sequential data is? Or text data. Okay. So You may have, seen on your, like, when you are writing on your keyboards, or like in your smartphone keyboard, for sure, smartphone keyboard, right? You have some buttons here, and on this screen you may have seen some recommendation. Let's say if you start writing Q, U and E, you will gonna see here, like, this button is recommending you queen. It could be possible. It could also recommend you quit. It is also possible. Okay, how exactly this is working? This is again a recommendation system which has been ingrained, or integrated in your this typing system, right? And also drug discovery is also there, with along with the natural language processing. Okay, not only that, Netflix. Okay, Netflix and or Amazon, they uses a technique called recommendation system, right? And this recommendation system, or like, let's say you have seen a movie on Netflix, and on Netflix you might actually get some recommendation. Let's say you have watched an anime. Okay, all right, let's say you have watched Hunter x Hunter, and based on that you will gonna get some recommendation. So what technique we are incorporating here is again a study, to study or research to do. But right now we have such powerful algorithms which can also recommend, based upon our choices, based upon our likes, what we might need in the future, or what we might like in the future. Just for the Amazon, you go for a shoe, shoe shopping. Okay, and you might actually type, let's say, Puma. All right, and you are in even in that you are actually going for the running shoes. So now when you will be seeing one shoes, like there will be another 5 or 10 recommendation, just because of that running shoes, and those 5 to 10 recommendation will going to be in the category of running shoes. How exactly it is happening, right? Okay. So that is how your machine learning systems are now capable of doing. All right, like super intelligent. All right. Okay, and now let's talk about, like, okay, now since we actually understood what the machine learning is, and how we actually interpret the data. But there is a thing, right? What exactly it is, like, each machine learning algorithm or each machine learning task has some different system, some different environment, and in according to that environment we have different tasks, right? We cannot, like, there is a, like, we cannot use hammer and chisel in machine learning just to solve every problem. Okay, so just to actually further extend it further, what we can do, we can segregate, or we can classify our machine learning system into three major categories. The first is, okay, machine learning systems. The first is your supervised. I will come back to it, what exactly it is. Supervised machine learning. This one is your unsupervised. And the third one is your reinforcement machine learning. Or I would say only learning, not machine learning. Okay. So let's actually try to tackle each one of those one by one. Okay. So what is a supervised machine learning algorithm? Okay. Just to keep it simple, when we have a definite class to predict or estimate. What do I mean by that? Let's actually try to understand this. Okay, let us say let us say you have a CSV data. Okay, let's say you have a CSV file. I hope you are all aware of what are the CSV files. Like, we also call it like comma separated values, right? Okay, these are the files. Okay, Excel files, not Excel, but the CSV files are different. Okay, let's say in that CSV file you have 4 columns. Sorry, sorry. Okay, okay, I'm just explaining a supervised task to you guys. Okay, let's say in that CSV file we have 4 columns. Okay, column 1, column 2. Okay, I'm giving it a name. Okay, even like, let's actually keep it more general. Okay, let's actually give it a name of column 1 and column 2. Column 1, column 2, column 3, and column 4. And here we have a class. Assume it, we have a class. Okay, and this data, and also, okay, I want to actually give it a, some information about the CSV. This CSV file contains data about dogs and, sorry, cats. Okay, so what exactly it's all about? Okay, this CSV file contains data about dogs and cats. Okay, so suppose again, coming back to it, this column 1 explains the nose, this explain ear, like, okay, column 2, this is your, let's say, tail length, this is your paw size. All right, based upon these 4, we are determining, okay, let me actually write here, based on all columns. Okay, we are determining if the, if the animal is dog or cat. Right, this is our task. So let's say the column here has a nose length. Okay, these all columns has a length, like these are all denoted as a length, and each you can actually consider the unit as a centimeter. Let's say I'm just making this, example up right now. Okay, I'm just making it up. Let's say the nose of this column 1 has, like, let's say 7 centimeter. Let's say ear has around like 14 centimeter, and this one has the tail of, let's say, 5 centimeter, and let's the paw size is, let's say, like it could be 9 centimeter. And based on these, like, like the nose, ear, tail, and paw, I'm telling you, like, I am actually determining, I am actually concluding this is as a dog. Okay, this as a dog. Okay, and the very next thing I can do here, like, let's say the nose is here somewhat smaller this time, ear is also somewhat smaller this time. Okay, let's say it's 11 centimeter, tail is somewhat longer. Okay, 8 centimeter, and paw size is also smaller. Okay, let's call it here 4 centimeter. And based on that, I'm saying, like, okay, this is a cat. Okay, so what exactly I did here, I actually took consideration of, based on column 1, column 2, column 3, and column 4. Okay, based on these, columns, I'm determining if my data is of a dog or of a cat. Okay, so this type of machine learning system is known as supervised ones, because you are given here a class. All right, okay, all right, okay, this task which we just saw just now is called classification. How easy it was, right? Right, this is your classification task. Like, when you perform a classification based on, like, from which class your sample actually belongs to. Like in this case, this part, okay, will be your sample 1. And this could be your sample 2. And now I can tell, like, this sample belongs to class dog, and this sample belongs to class cat. All right, okay, coming back to another, like this, that was actually a classification. Let's try to understand another example. Okay, okay, so let's say you have price. Okay, let me actually write it in a good handwriting. Okay, and also with different color. Okay, let's say you have price. Again, this is actually your column. Okay, column 1. Column 2, you have age, not the price though. uh, just a sec. Okay, let's say you have column 1 and this is your age. Column 2 is area. Okay, column 3 could be your number of bedrooms. Okay, column 4, let's say here, mm, garage area, or square foot, or area is already there, garage will just going to let's actually consider only 3. And here I have a class. Okay, and this is your price here this time, not the class, but label is here price. Okay, so what exactly is happening? Let's say this to give you a context, okay. Context, let me actually write here context here. Context above data, okay, from a housing file. Okay, housing file basically means like I actually had a housing data which had these 3 columns, sorry, these 4 columns. All right, and out of those 3 columns, out of those 4 columns, I had age, area, number of bedroom. Okay, let's say the age of the house is around like 5 years. Area is around, let's say, 1,000 square feet, let's assume it. Okay, number of bedrooms, let's suppose we have around here like 7. And based on that, like actually have it like in dollars. Based on that, I am determining like the price of this house could be 200K. Okay, and second could be like let's say 7 years. Again, let's shrink it down, 500 square feet, 5 bedrooms, and the housing price has dropped to 175K. All right, so say you have such data. Okay, this task is your regression. Okay, I will going to explain what exactly the difference between regression and classification just in a while. Okay, so what you just saw 2 examples of supervised machine learning system, along with 2 different techniques. The one was the classification, the second one is, which you just saw, is regression. Right? Okay, but machine learning is all like 99% of the times it's mathematics, and if you don't understand the math, you can never understand machine learning. That's actually a bitter truth. So, not a bitter truth, if you love math, then it's a pleasant truth as well. But if you don't like math, then I have a bad news for you. All right, okay, so let's try to understand this with the classification with the help of some sort of mathematical jargon. I wouldn't call it a jargon, but just a simple explanation, like how exactly it works. Let's say I have this function fx. Okay, I will try to chop it down bit by bit. Okay, and if people are not from maths background, just don't feel intimidated. Just ask question in the chat, and I will going to explain it for sure. But if you are from math background, it will be a treat to have with. Okay, just actually wait. So let's say you have this function fx, and you have this here x. This is your f1 of x. Assume it f1 of x, and this is your f2 of x. Okay, and this f1 of x has a somewhat this type of you know value, and this f2 of x has somewhat this. Like this is the f2 of x, and this is your f1 of x. Okay, so when you see such graphs, these are continuous one. Okay, and this f1 of x, okay, we have 2 things here. Actually, let me explain what exactly they are. So f1 of x has like 2 things here. First is domain, and the second is range. Okay, so what do I mean by that? Let's actually try to understand this. Let's say I have y barabar mx plus c, y is equals to mx plus c, and I can here as x can take X can take any values between minus infinite to plus infinite, right? And this is your domain for the function, with what value your y can take, and what value y can output is your range. Okay, value y can output here in this case is again, between, could be between minus infinite to plus infinite. And minus infinite to plus infinite, we usually denote that as r, basically means real values. Okay, all right. So when you have a domain, sorry, when you have a range, okay, which is which is which has, okay, which has a constraint, as follows: y belongs to r. In this case, we will going to conclude it as, regression task. Okay, that was your regression. And what about the classification though? We saw the classification graph as such, like, sorry, my vertical lines are never good. Okay, so we are, okay, now it's still not good, but somewhat doable. Okay, so this is your, discrete values. Right now, if I actually, like, this is actually a step function, like it's your x minus gix. Okay, like this is your fractional part. Okay, fractional part, and this is your real part. Okay, let's actually not get into the function itself, but what exactly it does, it returns this function, this f2x. Okay, this f2x actually returns only integer values. Okay, in this case this f2 of x is a discrete function. Why? Because it is not continuous. Okay, and now the classification basically happens on the cardinal value as well, but because I don't want to get into that, but classification is quite simple. When you have 3 or 4 classes or maybe 15 classes, you can determine, like, okay, this is simply a classification task. And when you have some continuous value to predict, like in this case, in the example which we saw, like it was a simple housing price prediction task, right? And we just simply, went with the y belongs to r. Simple. Okay, so those were your supervised machine learning techniques, and supervised machine learning system has those techniques. Okay, mostly when you will be dealing with the data. Okay, all right, is that clear to everyone? Blackboard is too dark. Is it visible to everybody? Server error? Really? Guys, if you are watching this stream on your smartphones, then it might not, give you better experience. Okay, sorry for that. So for a better experience, try to use your laptop or something. Okay. uh, all right. If you are seeing that this stream on, like on you, like on your smartphones. All right, so next is your what? Supervised unsupervised machine learning algorithm. Can you tell? Yeah, I can actually, I will going to take questions like in just in 10 minutes. Okay, so keep your questions ready, and like around 8:51 or 8:52, I will going to take questions for the next 5 or 7 minutes, and we can then afterwards we will going to end the session. All right. Sir, can I get a job in my 10%? I will come back to it. Okay. Okay. All right. So coming back to the second machine learning system or second machine learning type of we have unsupervised one. Unsupervised machine learning. You know what exactly it is. Okay. When we don't have a class or label, when we don't have a class or an estimate to do or estimate to predict. What exactly do I mean by that? Let's actually try to understand this. Okay, let's actually take an example of it. Okay, for example, okay, let's try to understand this with a credit card data, credit card transaction data, transactional data. Okay, so say you have such uh, data like in this manner. Okay, sorry, damn it, I just can't actually draw a simple straight line like I never did even in my. Now I can do it, I can do it. Yep, I did. It's still not that good, but just a sec. I think I have some options here. Okay. uh Okay, I don't think so. Yeah, there it is. All right, so I can actually have it as a line here. That is much better. It's still actually even after that I can actually let's actually have it as this. Okay, let's understand this in this way. Let's say this is your X plane and Y plane, and this is actually shows your expenses. This axis actually shows your expenses, and this is your frequency. Assume it. Okay, or range. I would call it a range. Okay. uh okay, let's actually have it as like let's actually segregate these expenses in some certain windows. Let's say like from 0 to let's say 20K in rupees. All these are in rupees. Okay, and this is your 30K, and this is your 40K. Okay, so what usually happens whenever you make a purchase, your purchase actually lies between let's say between this region. Okay, let's say you have only here. Okay, most of the times. Okay, and you also do some some but not this much, but you can also consider like you also do somewhat like here in this region as well, but not frequently as this 20 to 30K. So you have 30 to 40K, less than 20 to 30K. So what you do basically, you make more purchases between 20 to 30K. Okay, and less purchases between 30K to 40K. Okay. Okay, more and less. I would call it a more, and this one is less. Okay, and now what happened out of sudden? What happens one day out of sudden? Someone actually makes a purchase somewhere around here. Okay, and this one actually exceeds 1 lakh. And I think you may have even noticed, like whenever this happens, your credit card actually gets blocked automatically by your company, like by your bank. Okay, with this type of algorithms, okay, can actually help you. Like this was actually a novelty detection problem. Okay, all right. This was like, okay, this is again your unsupervised machine learning technique. Second example that you can see here, let's say you have pixel data. Pixel basically, pixel is an image data. Like pixel, what exactly the pixel is? Smallest unit of an image. Okay, which actually ranges from where 0 to 255. Right, 0 being the darkest and 255 being the brightest. All right. And now let's say you have pixel data, and pixel data here is like, pixel 1, pixel 2, pixel 3, dash 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 pixel, sorry, pixel 784. And this combination actually forms, okay, if the data is of, if the data and then the, the values that we have 0, 1, 2, 9. And certainly we already have a label, but we can instead of going with the supervised one, we can also go with the, unsupervised one. How exactly? Let's see. Okay, what we can do with this pixel data, we can form small clusters. Okay, we can form small clusters. Okay, and based on these clusters, we can determine like if this cluster and if this cluster and if this cluster and last one is this. Like if this, if like let's say these are fours and these are fives and these could be like twos and this could be like nines, right? These all clusters can we can actually segregate based on their pixel values, and this technique is known as clustering. Okay, and again, this is your unsupervised machine learning task. Is it clear to everybody, like what exactly it is? Okay, all right. Okay, if you don't, just prepare or keep your questions ready. I will come. I'm coming back to that. Okay, and last but not the least is your reinforcement learning. All right, and what exactly it is? Let's say, let me actually give you a more general example of it. Uh, let's say, you have a dog at your home. Okay, and like it's a 10 or 12 days puppy. Okay, and now what you want to do, you want to train your dog like when to sit, when to roll down, when to play dead, and so on and so forth. And what you do basically, let's assume like this box is your dog, because I'm really terrible at drawing dogs. Like I'm terrible at drawing itself, but dog is not an exception here. Okay, so let's suppose like this box is your dog. Okay, and now what we can do, we can actually propose, here a policy. Okay, and this policy works as follows, based on rewards and punishments. Okay, and this dog will be fed an action. So let's say your dog actually performs which you may like as an action. Like let's say you ask your dog to, let's say the action was, let's say you actually gave your dog an action, like uh, uh play dead. Let's say you play dead, like, okay, or fetch ball or something. Fetch the ball. Okay, let's actually give it as a fetch the ball. And your dog actually performs it correctly. And what you do here, you give it a reward. And this reward is your here positive reinforcement. Okay. And let's say you again ask the very same question. Okay, fetch the ball. Sorry. Okay, fetch the ball, and you go it here, but this time actually it doesn't actually perform. And this is again will be a punishment. This will be a punishment, and this will be your negative reinforcement. You know. So we try to maximize this reward while minimizing the punishments. Okay, so what we do basically, we train an agent, okay, based on the behavior which we find correct. Simple. That is your reinforcement learning. In this case, your agent is dog, and your behavior, you have literally separated that behavior with positive and negative reinforcements. That's it. That is your simple reinforcement learning. Okay. All right. Okay. So these were your machine learning systems, which we just covered. Okay. And now I can take questions. So if you do have any questions, then please ask those questions on the chat, and I'm now taking questions of yours. Okay. Please do. I insist. No questions? Come on, guys, ask questions. Machine learning is still similar to cron jobs. What do you mean by that, Vijay? I don't understand. What do you mean by cron jobs here? Real world example for classification regression. I just gave you real world example, Akash. Determining if an image is of a cat or a dog is a real world example. Determining if we want to buy a house, determining a price of a house is a real world example. Okay. Why am I drinking Nadal Pani? That is actually, why shouldn't I, by the way, Abhinav? Just tell me. Why shouldn't I drink Nadal Pani? Just tell me, and I won't drink it ever. Cron jobs and what type of language is C, C++, and what type of language C, C++? Like, what is the question? What type do you want me to? All right. Compile type is C and C++. Python is a scripted language. Okay. Is ML necessary in data analysis and business analyst? Well, data analysis is a part of machine learning and like data science in general. So data analysis is something that you will always gonna do, like when you will be tackling a machine learning problem. So 80% of the time you will be dealing with the data. So you need to know what the data analysis is. So yes, what type of language is machine learning? What type of language is machine learning? Machine learning is not a language. Machine learning is a technique, or I would say a field of study in itself. I can perform machine learning even without a language. Do you really think like Python or data science or Python or NumPy or Pandas actually is machine learning? No way. Actually, statistics along with some prediction techniques is machine learning, right? So okay. So I am having problem with the attendance. Like, will we get certificate after the class? I think moderator can answer this. Will we do any programming in this? Yes, we will. We will gonna do, like, that was actually your introductory class, and from tomorrow onwards we'll be delving into the programming. I will be teaching you some important aspects of how you should actually tackle a machine learning or data science problem in journal. Okay, like we won't be delving into the details a lot, but definitely after having four essentials straight in a row, you will be having a better understanding of to tackle a problem. Like, okay, how can you proceed with machine learning task or a data science project by having those checklists in order. Okay, how many more classes? Four. A coded language, sir. A coded language, but okay, I don't understand your question, Goyal. And how many more class? Four. Can you tell me the whole schedule? All I have good scope in the future. Will AI have good scope in the future? As the data is, I don't see like why not, but the data accumulation is getting into like in petabytes, like in each day, every day, and data accumulation is somewhat having an exponential growth. More the data is there is, and the more the AI we can definitely use. Okay, and can you tell me the okay, what should for machine learning, the math, like it should be linear algebra, probability and stats, integral differential and integral calculus should be somewhat a prerequisite, like in order to become a good machine learning engineer or data scientist. Okay, and you cannot escape that. You are an amazing teacher. Thank you so much, Rehan. Will there be any job assistant? No. Which programming language use this course better, Java in Python? I would prefer Java. I would prefer sorry. I would prefer Python and never Java. Okay, never do that Java. Okay. Will there be any job assistant after this program? No, I don't think so. Uh, is machine learning tough to learn? No way. Why? It's not at all tough. Okay, machine learning, like, just consider, like, I believe you may have actually, performed, or you may have actually done those graphs in your childhood, when we were given a question and you just have to perform that, you have to mark it up, like where data actually goes and where the data actually, should be, and you basically join those lines, right? So that is where, like, like that sort of understanding, that sort of a view that you need to have in order to tackle a machine learning problem. I see machine learning problem, like whenever I have to imagine, like my built-in mechanism, or view of understanding a machine learning problem is always on a Cartesian system, or I would say an XY plane or XYZ plane for a hyperplane, right? So try to imagine data in a vector form or in an XY coordinate system or in a Cartesian system, and your problems will be resolved most of the times. Okay. Uh, which framework used to run machine learning program? Framework, you can use sklearn, right? Scikit-learn, which we say, and for the machine learning, okay, and for the data analysis and scientific computation, you can certainly use NumPy, Pandas is there. For the visualization, you can use Matplotlib, Seaborn, and for the deep learning, when we actually get there, so you can use some simple TensorFlow or PyTorch. So, what will you teach in this class? I just taught in you. I just completed this class, dude. What you will teach in this class? Okay. I'm from Jaipur. Hey, I'm from Jaipur too, Avishkar. No, the installation. Okay. Try to have Jupyter, NumPy, Pandas installed in your system. Okay. Okay. Different between class and regression. I believe I just explained. Class is something that we have discrete values as. Regression is when we have a continuous value. Please provide the class PPT. Uh, I will try to do that for sure. Okay, I will try my best to provide you the class PPT. What about the certificate? I think moderator can answer it, right? Which Python points use in ML? Which Python points? I just explained. Python is not machine learning. Python just enables you to write machine learning code. That's it. Python is not machine learning. Just to let you know, Python, even in Python you can write web application. So now you, if you are getting my point here. Yeah, if you have Anaconda, is deep learning important to ML? Deep learning is somewhere you actually want to mimic your human brain, and you have computational graphs. So that's where we can actually, sir, if someone doesn't know coding, can they do ML for job? Definitely they can do. Okay, but there will be another coding language, then you can actually prefer R, just to actually get your machine learning tasks done. Like it doesn't actually require you to have a heavy coding example or heavy coding experience. But yeah, like, but I would actually tell you, like, I would actually recommend you, like, get your hands dirty with the coding. Link for the attendance. Is VS Code well enough for ML hands-on? Yeah, like, it's Jupyter Notebook is also well enough. All right. Anything else, guys? Just let me know. Can you suggest some good coding tutorial for learning ML? Coding tutorial just to learn ML is totally an ambiguous question. I can actually tell you what the code, like, what coding language you should actually be learning from. Like, try to use automate the boring stuff with Python book. Like, it's quite a good book, and you'll be having a better understanding of and basic Python itself. And all right, okay, sir, is it juice or water? It's पानी है यार, नारियल पानी है. Okay. How many coding languages? I basically use Python, and I also now I have started to use JavaScript too. Can you give an example of unsupervised learning? Credit card fraud detection, Rohit. Uh, Classification can be determined, and regression is a kind of a guessing. Yes, kind of. Yes, Ritvik. Any more questions? Guys, ask questions. After this course, will I be able to create projects? Well, it depends. I just don't want to give you, do you know programming in journal? Do you know, like, 99% you won't. You will be having an understanding of what machine learning, is all about, and data science is all about. You can certainly create low end projects, like which are not that much complex, but to showcase on your resume, I think you might need some experience. Well, let's upgrade certificate enough to get ML jobs. Okay, just to actually add on to that, no certificates are enough to get you a job, let alone let's upgrades. Happy? Certificates are a hokum, honestly. Okay, and when you don't have a real world skills, and you don't know how to tackle a problem, no company will going to hire you, or you going to put any efforts in you. So rather focus on yourself, rather focus on your building skills, than to have certificates itself. How this course helped me in campus placement? Showing your no. Yeah, it will, if you are willing to learn. Okay. So can you please explain? I want to. Okay. Uh, all right then. So I think we are pretty much done for today's session, guys. So, sir, please explain coding example using Python live tomorrow. Yeah, definitely, definitely. From tomorrow onwards, we will just gonna see a lot of code, lot of code, lot of code. Okay, don't worry. Can you please give some example? I just gave you. Okay, credit card detection is there, and recommendation system is there. Clustering, like novelty detection is there. Okay, can you, sir? Could you just suggest that skill that the link is showing? Okay, sir, could you suggest that skill that needs no coding? That video editing, I believe. Goyal, you just ask a question like, could you just suggest that skill that needs no coding? Video editing, you can try video editing. Just kidding. Not kidding, by the way, but that is actually true, right? Voice recognition bot is also, yeah, definitely. Uh, all right, guys. Then okay, so I'll see you around tomorrow this very time, and with my Nariyal Pani again for sure. Okay, and is this any certificate, or you just make people fool? I don't know. I just gave you some, insights about machine learning. If you feel like you have been fooled by my teaching or something, please, feel free to not join here again. All right. Uh, thank you so much. Thank you so much for joining in, guys. Okay, it was great, essential and great session. Okay, and I'll see you around tomorrow this very time, and we will just going to dive into a really good coding stuff, and we're just going to try to understand machine learning itself from the scratch itself. Okay, how exactly a machine learning model actually learns. So what I can actually ask you to have something, just try to have some basic understanding of differential calculus. Oh yeah, let me actually ask you this question. How many of you know this differential calculus? Like, how many of you can perform differentiation? Just let me know, like, is in me, I can. Okay, sure, yeah. All right then. So, okay, that will be great. That will be totally great then. Okay, so uh, let's meet. Let's meet tomorrow. Okay, and we will be having a great a session for sure then. Okay, and all right, guys. So again, thank you so much for joining in. Okay, and I'll see you around here. All right. And it was actually a great experience always. Like to teach anybody is always a great experience because you also learn in that process, right? So all right guys, so see you around. मिलते हैं कल इसी टाइम पे, ठीक है? Bye bye, good night and take care. All right, and stay safe. All right, bye bye. Can I get a job my 10%? No, no, definitely you can. Okay, no one can stop you. Okay, to actually give you this last. Okay, yeah, you can get a job. Okay, so all right, bye bye. Okay.